So thank you all for joining us today for this GEA presentation. It is about diversifying your craft portfolio with seltzers and de-alcoholized beverages. So we're very happy to join the Craft Brewery Conference here in Denver, Colorado, and I want to thank you, all of you that are going to dedicate your time today for this presentation. So just a brief introduction. I'm Pierpaolo Materna. I'm the head of sales for beverage and filling technology for GEA, based in Hudson, Wisconsin. I've been with GEA for more than 20 years now, and I have basically responsibility for the beverage and filling technologies here for the North America group in GEA. Eric is part of our sales team. He's a regional sales manager based on the West Coast, and has been with us for more than 2 years, and is going to help me with the basically rest of the presentation here, more on the technical side. You have our email addresses here, and please do not hesitate to reach out direct in case you may need that additional information, technical details, commercial offers, and whatever. So we will be willing to follow up with you, whatever your needs are going to be. This is a brief agenda for the presentation. I'm going to start with a brief GEA introduction, and I'm going to go into products and trends. Then I'm going to let Eric proceed with the seltzer and the de-alkalized beer production. We're going to give you an idea about the process and the equipment required for the production, including mix and blending and downstream processing. And we're going to finish with a presentation dedicated to our flexible filling technology, the all-in-one from GEA Vipo. And we're going to leave some time for question and answer. So GEA is one of the largest technology suppliers for food and processing, and a variety of other industry focused on technologies, components, and sustainable solutions for sophisticated production processing in diverse markets. So what we represent today here is the liquid and power division, where we are specialists in design and engineering of processing equipment and integrated solutions. Industries, we are very well basically introduced in the brewery and the beverage industry. That's where Eric and I belong in the GEA organization, but we also have a dairy and in food division, chemical and home and personal care. Technologies, we can provide beverage and filling technologies, liquid processing technologies, powder technologies, chemical and emission control technologies. We have a strong presence here in North America, where we can provide you service, installation, commissioning, and after-sales services, and we have competencies in product and process development, process design, and project management, execution, and automation. As you said, GEA is very introduced in different industries here in North America. Just to give you an idea, on the beverage side, 50% of, that's an estimate obviously, but we estimate that 50% of the beer produced is with the aid of a system and solutions provided by GEA. So this is where my office is, in Hudson, Wisconsin, and this is where the beverage group is headquartered in North America. We have 200 plus employees. We have a facility of 25,000 square feet, and we have manufacturing and warehouse. We also have offices in Columbia, Maryland, where we have basically another 170 plus employees with a test station and warehouses. Now let's get into hard seltzers and de-alcoholized beer market trends. So hard seltzers, yeah, they experience a tremendous growth, and yeah, if I don't think they will be growing with the same rate they have been growing in the last 2 years, but they are definitely here to stay. There's no question about that. They are certainly considered a healthy product. This is probably because they have low carb, and that's why they are trendy. This low sugar concentration is considered critical for health. And yeah, and they have this seltzers word, and the word seltzer is widely understood as water. So in general, they have less alcohol than vodka and soda, for example. Lifestyle, they definitely have, they are a convenient lifestyle product. So they come with this small can and a sleek can, and they are portable. They have this stylish design with this very nice printing, and they also have this modern and refreshing flavors that are appealing to all age groups and gender neutral. So let's enjoy them together. So that's the message they transfer. So the market, as we said, is continuously growing, and research shows that they are taking market share across the board from the alcoholic beverage industry, but most of the share is coming from the beer category. And yeah, as you can see on the right side of the slide, we have basically sales, hard seltzer sales before and after the pandemic. We can see that the pandemic didn't affect much the sales. Actually, it continued to grow also during the pandemic. Obviously, there are new trends. It's a relatively new product, but we can see new trends in the market every day when we walk into a liquor store, and we see all these new brands and SKUs available in the market. So certainly USDA organic is a message that we find in some of them, gluten-free or flavor added using real fruit, presence of antioxidants, obviously low calories. They always start with this strong message about low calories and sugar-free, and we are seeing more and more brands introducing high alcohol grade hard seltzer, and they're becoming more and more popular too. So yeah, another product that is obviously increasing market share is de-alcoholized beer, and it's certainly for health conscious consumers. It's a low calories, there is little or no alcohol, and they can be a great alternative to, for example, a soft drink. There are some particular case where it's a demand, for example, pregnant women or nursing mothers, or people that simply abstain for other reasons. And there are new technologies that have been helping recently to create very high quality products. The market is continuously growing, and basically, as you can see, 2020 it was a 17.5 billion market, and globally, but basically we expect to see it growing up to 30 million up to 2028. Good. So this is the first part of the presentation. I'm going to let Eric go ahead and continue basically going into the process details about producing hard seltzers and de-alk beer. And yeah, I'm going to reconnect with you guys at the end, and I'm going to basically present you a specific part of this presentation dedicated to our packaging solution. So Eric, it's all yours.
Thanks, Pierpaolo. Hello, everyone. Thank you for joining us online. As Pierpaolo mentioned, I am the Western Regional Sales Manager for GEA for brewing and filling applications. I have a long career in beer, studied brewing and fermenting chemistry from UC Davis, and have worked at both large and medium small breweries across the country. So with that, I'm going to be talking today a little bit about seltzer and de-alk beer production and how those two are related, as well as some other options for mixed blending, downstream processing, before I hand it back over to Pierpaolo to talk about the all-in-one. So we'll start with seltzer. So what is seltzer? For those of you that may be newer to the game, what's inside. There's basically four main ingredients, and the first being water, the primary ingredient in any seltzer. And so when we talk about water, water quality is very important. The mineral chemical content of that water is used for both flavoring, quality, and consistency. Also has impacts on fermentation, filtration, specifically membrane filtration, as well as finishing. Second major component being alcohol. Is a side note, in the United States, at least 51% of your alcohol must come from the fermentation of a carbohydrate to avoid a higher tax burden. If you do some comparison to other countries such as Canada that can use basically grain neutral spirits. So one advantage to using membrane filtration is that you can avoid that. The alcohol can be fermented from either a malt base or a sugar base or the combination of said ingredients. And from an alcohol concentration, typically what we have been seeing in the market is around 5%, though as Pierpaolo mentioned, trends are changing. We've seen much higher, up at 8 and even 12%. Carbonation is typically higher than what we see in beer, around 3+ volumes. And then of course the flavoring aspect, which is limitless, for everything from fruits to botanicals, sodas, everything else. So the principal process of a hard seltzer production, we have the makeup of the fermentable sugars, then we have the fermentation itself, the decoloring and deflavoring, which is how we produce what we call our neutral alcoholic base, and then blending and mixing. So as far as the makeup of the fermentable sugars are concerned, we talk about there's several different ways to do it. We can use a wort base coming from the brew house. We can use liquid sugars. We can use dry granulized sugars. We can use fruit sources or other gluten-free sources. In regards to fermentation, we typically see specialty yeast strains and as well as yeast handling. Mostly dried yeast are used in the industry currently. And that for reasons targeting anywhere between an 8 and 18% ABV coming out of fermentation. One thing that we offer is called our jet mixing equipment, which is used for the optimization of the fermentation, which I'll talk about in a little bit. And then following fermentation is the first filtration of the beer using centrifugation. Post-centrifugation, we look to really remove all of the other attributes from our neutral base that we want to remove, being colors and flavors. So we utilize membrane filtration technology to do that. And end goal being to have the cleanest, most neutral base that you can achieve. We typically use and focus in on two different types, those being nano filtration and high pressure reverse osmosis. Once we have our neutral base, then we go on to blending and mixing, where we are going to then basically add water, flavors, sugars, colors, potentially if that's what your product requires, and then further on processing of carbonization, flash pasteurization, and then packaging. So we'll start with the wort or sugar-based production. So GEA offers several different technologies to handle either and or all. So full flexibility in raw materials, the equipment for processing of sugar or cereal malt bases. When we talk about brew houses, we have state-of-the-art brew houses for all production sizes, starting with our newly introduced Craft Star M, which is a fully automated 20 hectoliter brew house. Followed up by the Craft Star XL, which is our 40 hectoliter brew house. Larger brew houses are Compact Star between 40 and 125, and then of course larger for larger breweries. Outside of the brew house, we offer solutions for raw material handling, liquid sugar receiving, sugar dissolving, whether you're using liquid or dried sugars for your sugar bases, as well as thermal wort treatment prior to fermentation, utilizing our EcoFlash pasteurization system. And of course, importantly, is aeration going into fermentation, utilizing our WortStar technology. So all of these, obviously we're covering a lot. If you have questions in regards to any of these specific technologies, please feel free to reach out after. So now that we have our base produced and we are going into fermentation, we look at how do we optimize that fermentation. And our solution is what we like to call jet mixing, which we'll talk about here in a minute. But first, we want to understand what the goals are, specifically in regards to a neutral base fermentation for seltzer. What are the goals? So we want high alcohol. We want to have a really good fermentation. We want to have a high attenuation value. Typically, we want a fast fermentation, and that's in relation to tank turnover for capacity reasons. We want a relatively clean base, so we still have to approach our fermentations utilizing our skills in brewing. We do want to reduce unwanted volatiles, and of course, from dollars and cents, we want the highest yield possible, reduce extract loss. What are some of the challenges associated with those? ABVs, we talked about wanting to have high ABVs from the start, 8 to 18%. That can be a challenge depending on what type of yeast you are currently running. There are multiple yeast strains on the market. We get a lot of inquiries into what types of yeast. Typically, we see dry one-way yeasts, but we always encourage customers to reach out to your yeast suppliers. There are a few out there, especially the big ones. Contact your yeast supplier, tell them what you're trying to do, and they will certainly guide you from a yeast standpoint, and also, just as importantly, a nutrient supplement. So as I just mentioned, one-way yeasts are typical. We also add nutrients. So there may be some challenges there from your needs to hydrate yeast and or nutrients. We also offer those solutions here at GEA. The residual sugar component post-fermentation is something that can be of a challenge, has an impact on your overall extract recovery, and then specifically in regards to membrane filtration is something we like to avoid. We want to have a very complete fermentation because, again, the membranes that we're going to be talking about basically reject all sugars, salts, so on and so forth. Temperature-wise, there's varying fermentation profiles that are used. It's very customer specific depending on what your base is and what kind of yeast you are using. But in general, we typically see very warm fermentations in comparison to what would be like a standard beer. Pasteurization, as I mentioned as well, is optional for your sugar base going into the fermentation. If you don't have a brew house or you're going to bypass your brew house, it may be an equipment need that you need to pasteurize prior to fermentation. So as far as the fermentation optimization itself, we look to what we call our GA liquid jet mixing system, which is used for increased efficiency during all cycles of fermentation, mixing, cooling, and fermentation, typically installed in vertical conical tanks. And essentially what it is a specialized jet nozzle that's inserted on top of the lance that is inserted from the bottom of the tank. And the idea is to recirculate your product through this Venturi style nozzle, which mimics and enhances what would normally be the natural convection created during fermentation. And the actual components themselves are designed based on your tank geometry and your batch size, what you're trying to produce, etc. The system can also be adapted for other things outside of fermentation, such as general mixing of other flavors or additives. So we, in many installations, will use this technology for just that, for the mixing of flavors downstream. So some of the benefits that we see when utilizing jet mixing are increased ABV, so higher alcohols coming out of fermentation, better attenuations, higher RDFs, which is in result lower residual sugar, which is very important, as I mentioned. Improved consistency and control of the fermentation, so batch repeatability, reduced time of your fermentation, maturation and cooling. So we start recirculating as soon as the lance is covered, all the way through fermentation, maturation, and then if you decide to cool your tank, which isn't necessary, but some people believe they should, a faster cooling rate. Also important from the homogenation aspect of having a well-blended fermenter, essentially. Post-fermentation, when you go to send that liquid downstream Through the centrifuge, you have a much more consistent centrifuge run because you're supplying the centrifuge with essentially the same solids throughout. We also have the ability to offer instrumentation, inline instrumentation, if you want to have real-time inline measurement of cell counts or OG, whatever you desire. So post-centrifugation, as I mentioned, centrifugation is next in the process flow. So all of our centrifuges, which there are many out there, and many of you I'm sure already have, the centrifuges meet the necessary turbidity requirements for the downstream processing through membrane filtration. In essence, no further processing, de-filtration is not a requirement. We see above a 99% cell removal, higher yields, reduced losses. The entire tank volume can be processed through the centrifuge. Full flexibility in the actual equipment itself. So we offer multiple sizes of centrifuges, from small micro pub size all the way up to full on large scale breweries, and versatile. So it's not just for seltzer production, it can also be used for other production, for those of you that are not as familiar, for beer. And as you can see, just from a reference standpoint, we have over 500 installed currently in North America. All right, on to membrane filtration. So we utilize membrane filtration for both hard seltzer filtration as well as beer de-alkalization. In both instances, we use polymeric spiral wound membranes to basically, in the seltzer world, create virtually a neutral base with no flavor, aroma, or color. All of the units are skidded, they're modular and compact, they're expandable, which is great for breweries that are growing. They're pre-assembled, they're built with the sanitary execution, utilizing mixed proof valves. We have the ability to do batch process or continuous plant operation. That continuous would be for a larger scale brewer. And then most importantly, I'd say we have a lot of experience in this area with over 75 membrane filtration plants currently used around the world. As a side note, which I'll get into, is that we can adapt this technology for seltzer production, but also beer de-alkalization to produce products of, beer of 0.5 all the way down to 0.05%, whether it's beer or cider. And as a side note, which we'll also get into a little bit later, is that that quote unquote waste stream from the de-alkalization process can then potentially be used for a seltzer base. So first, we want to understand what the differences are in filtration. As brewers, a lot of us are familiar with traditional filtration, where you have a single feed passing through a filter media and have a single filtrate. So an example of this would be sending your beer through a DE filter to remove hops and yeast. So those large particles are trapped in and the liquid is allowed to pass through. If we compare that to a cross-flow filtration, we have a single feed, and then we have a membrane, which is microscopically selective to whatever components we're either trying to keep and reject or reject. So we actually have two streams coming out from the feed. We have our filtrate, which is also known as our permeate, or our retentate, and or also known as concentrate. So the types of membrane filtration available start at microfiltration down to ultrafiltration, then nano and RO. As you can see, coming down the chart, the pore size essentially on the membrane shrink, and you are able to get an increased purity and or higher rejection rate of certain components. And then going back up the chart, we look at a higher increased throughput, again related to pore size and surface area. In the seltzer world, we really hone in on the nano filtration and the RO. And then when we talk about beer de-alkalization, we primarily just focus on reverse high pressure reverse osmosis. So just looking at the anatomy of one of these polymeric spiral wound membranes, you can see here kind of the breakdown of it. Single feed solution coming in, The membrane itself is wrapped and is composed of the membranes itself as well as channel spacers. So depending on what product you're running, what you're trying to achieve, the product is able to pass through the membrane to the permeate side, and then what is rejected that does not go through is your secondary stream, which is your concentrate or your retentate. So for seltzer production, just kind of the principal idea, looking at it from a 1,000-foot level, you have your feed, your neutral base that you fermented and centrifuged anywhere between an 8 and 18% is typically what we've seen. There are going to be some residual sugars. There's going to be all your minerals from your brewing process. There will be some color and then of course the flavors, which is what we want to remove. Through the process, we have our two outstreams, our filtrate, which is our purified ethanol solution. You can see here, this is a typical example of, and actually of a sample that we have processed at our facilities in Hudson. So even though the neutral base looks pretty clear, when you look at it, when you put it side by side post treatment, it is pretty remarkable. The concentrate, which is your retentate, does contain some ethanol. But all of your sugars, minerals, colors, and flavors, the things that you don't want in your seltzer. As far as the different types of units that we offer, as I mentioned, both batch operation and continuous. Continuous being for the large brewers here at CBC, we would be focused more on the craft brewers' needs. So we offer a variety of solutions from our smaller ranges of 50 hectoliters per day up to our larger, more automated skids that can produce up to 500 hectoliters a day. You can see we offer different sizes, fully and semi-automated versions depending on your need. So that was seltzer. We'll jump into beer de-alkalization, and you'll see how there are some similarities. In regards to brewing beer, just for those of you that may be new to GAIA, we offer complete solution coverage for all things brewing, everything from malt handling through our innovative packaging. But today, I think we're going to focus a little bit just on the membrane filtration side of things, as well as the all-in-one. So what are the technologies out there? There's the biological methods. Whoops, slide jumped. We have the biological methods, which are utilizing, either stop fermentations or specialized yeast. We have the membrane filtration utilizing cross-flow filtration technology, which is what we're primarily talking about today. And the reason for that is that here at GAIA, we believe that it produces a far superior product than the other two technologies mentioned here. The third being the thermal process, vacuum evaporation or distillation, which has probably been the most common and been around for the longest. So the principle of beer de-alkalization utilizing membranes is you're going to basically supply the unit with what your typical beer would be. The numbers here say 3 to 8%. That's not a hard stop. That's just kind of an example of what we typically see. Your beer is going to contain all of your color and flavor. We have our unit, which we utilize reverse osmosis, similar to the seltzer filtration, and seeing the typical similar things coming out. So on the filtrate, we have the water and ethanol, which we're going to remove from our beer, and the retentate is now all the things we want to retain, which is color, flavor, and aroma. There's three primary steps in the process, one being the pre-concentration step, the second being difiltration, and then a final blending to sales gravity, essentially. And we'll walk through those now. So here's our first step, our pre-concentration step. So we have our batch tank, our source tank, which is going to be your post-fermented and we'll say base filtered beer. What that means is that it has at least gone through some basic filtration process, whether that's centrifugation and or just pulling off main yeast from your beer. The equipment is capable of running both yeasted, hazy beers, or clear beers. The main point being here is that you just have to have the primary yeast removal. So once we start the process, we feed the RO system with our beer, and we have two streams coming out, as mentioned before, our water and alcohol solution, and then our concentrated beer going back to our source tank. There are no membranes that exist that are only selective to ethanol. Therefore, we have to end up removing water as well. So as we are removing that water and ethanol, of course, we're going to concentrate our base tank. The volume will drop, viscosity will increase. So at a certain point, then we will need to introduce deaerated water, in which we call Difiltration Water. And this is the process of essentially adding that water at the same rate that we are removing. And this acts to essentially rinse the alcohol from your beer. Very similar in theory to what you do in the brew house, where you're during sparging, when you're rinsing the sugar from the spent grain. In this case, we're just rinsing the alcohol from the beer. Once we have removed enough liquid, enough alcohol, then what we will do is then back blend our deaerated water back to either your starting gravity, or depending on what your sensory profiles tell you, you may want to go a little bit lower than your label claim. We've seen that very common, that 0.5% may be your label claim, but actually from a sensory perspective, you're happier at 0.4, 0.3. So just kind of walk through to see the process in motion. The first step is to fill our batch tank, which you see here. We start our process through our RO skid in the pre-concentration step, and here we are removing the water and ethanol. As a side note, that the water ethanol solution that's being removed at this point is essentially the same as whatever your base beer is. It will actually be slightly lower, but it will be relatively close. So you're starting with a 7% IPA, you're going to have a 5.5%, 6.5% water ethanol solution coming off the membranes into this tank. And so one consideration for this process is what to do with that liquid. There is the potential to utilize that for other products, i.e. seltzer base. Then we start the difiltration process, adding the deaerated water to rinse the remainder of the alcohol. At this point, the ethanol coming off of the plant is going to drop pretty quickly, like similar to what you would see on a curve during sparging. So the decision can be made from the brewer whether to continue to collect this and utilize it for a seltzer base, or to maybe only keep the first portion for a seltzer base and sewer the rest, or to collect that and then use it for other processes, maybe a pre-rinse on a CIP, so on and so forth. So after we've finished that process, we do our back blend back up. So essentially what we've done is removed water and alcohol, and now we have just replaced that water and of course not put any alcohol back in the tank to create your de-alkalized beer. From there, we can treat this as any other beer. We can discharge it either to carbonate it, send it to pasteurizer, and or to the filler. We could also do further treatment. Maybe you want to add some flavorings, or maybe you want to go back and dry hop it again. That's a completely customer specific. Take a sip of water here. In regards to the CIP, the units are equipped with the filtration plants are equipped with their own CIP tank and system. We utilize special chemical during the CIP, specialized caustic and acids, as well as a storage solution for the membrane plant when it's down. They're readily sourced from your normal chemical supplier. Another side note is that the CIPs themselves typically run a little bit cooler than what you're probably used to in the brewery. And again, that's because you have sensitive membranes in the system. Everything outside of the plant is CIP just as you normally would. And then, as I mentioned, a special storage chemical. If you're not going to be running your filtration plant around the clock, then you would essentially pack the system with a specialty solution to keep those membranes fresh and ready to go. For beer de-alkalization, sizing and throughputs. So as I mentioned earlier, as same in the seltzer world, that we offer different size plants. What we call our Model S, M, and L for small, medium, and large. Here you can see the number of housings associated. So our Model S is going to be our more simplistic, we'll say small scale version for either a small craft brewery or for research and development. A single housing that can be house up to 5 different membranes, and the associated throughput for those. One thing to note is that the Model S is going to come with basic controls, instrumentation, but no automation or sequencing. When we step up to our size M and L, they will come with a PLC, sequencing, touchscreen, things like that. So better for breweries that are looking to do more actual production. The other side note as well is for the size M and size L is that we have the capability of expanding, as I mentioned before. The size S does not, but the size M and L, you could build it out starting with two housings, and then if your business continues to grow, sales are good, you could easily expand it to 4. So again, a lot of numbers on the slide. If you want to go more into depth, feel free to reach out to me later. Comparing some of the technologies, and in this example, we're just comparing cross-flow filtration versus distillation. From a quality standard input, my feelings is the big thing is temperature. You're able to process the beer through cross-flow at a much lower temperature than you are to distillation or even vacuum evaporation. We're looking at less than 10 C, so low to no thermal impact to the beer. Aroma losses, I've tasted a lot of de-alk beers at this point, and I would say, in my opinion, that the beer quality coming off the membranes is significantly better than the other technologies offered. CapEx, relatively low investment up front, and then ATEX, explosion proofing, something that may not be considered by some. It's not required for cross-flow filtration because, again, the alcohol that's coming off of the system is never going to be higher than what you started with. Looking at some of the advantages from a brewer's perspective, the full flavor aroma retention is a big one. So all of your, as I mentioned, all of your flavor, aroma, and color compounds are staying in the beer. You're not beating the beer up with heat, you're processing it cold. You have the ability to innovate, so not just completely beer de-alkalization, but potential reduced ABV beer style session beers. An example I kind of came up with was I've never seen a double IPA session. I don't know if it would be any good, but the point being that you have the ability to create the beer you want. You can make multiple products from one base beer. You could have a flagship IPA, for instance, and perhaps now you have your flagship IPA in a de-alk version. And then perhaps you take that de-alk version and you do something else to it. You add puree or hop extracts. And then at the same time, now you can recover the alcohol that you pulled off of that beer and put it into a seltzer stream. Really, the idea is just the flexibility that you can create whatever products that you want and decide what ABV you want later. One sort of caveat I put when I talk to customers as well is that the membrane filtration plant, in theory, it's not a magic wand. You still have to utilize your brewer senses. One thing we've seen is enhanced perceived bitterness after beer de-alkalization, specifically for IPAs. So there may be some recipe tweaks that may be required just to hit whatever sensory profile you're looking to achieve. The technical advantages, again, I mentioned you don't have to do clear beer. You can do filtered or unfiltered beers. Modular in design, again, expandable. Everything that we do is designed hygienically. We utilize food grade membranes, of course, that are FDA approved. Compact and skidded, utilizing full automation. If you go with one of the larger units, medium-sized units, and that integrated CIP. Just thoughts from a brewmaster, one of our customers, Gary Loyne, up in Central City, out of right outside of Vancouver. He is currently using our system for his street legal series, and has been very happy with the results. And you can see the testimony there. After trying different technologies, they themselves were very impressed and have been moving forward ever since. So some of you may be thinking, all right, I want to try it. We offer a couple different options for trialing and piloting with us. The first option that we have is what we call our Model R, which is a small condensed version of our filtration skid that you can bring into your brewery. This wouldn't be used for any means for actual production, but could be used for proof of concept, trialing different membranes, process optimization, so on and so forth. So you can bring this in, like I said, to your brewery for a few months to try it out and develop your recipe, so on and so forth. As Pierre Paul mentioned, we have our main office in Hudson, Wisconsin, where we have manufacturing facilities and warehousing. And we also have a pilot facility there in which we can run both either seltzer filtration, if you have a neutral base you want to try, or if you want to send beer to be de-alkalized, you can also do that. And that's what's depicted here. You know, a couple of things. You can see just the seltzer recap. But in this picture here, this is a setup for beer de-alkalization, where we have our source tank, our batch tank. So you would ship us some kegs, and the beer is transferred into the source tank, and then we run it through our single element membrane skid here. And then we also on site have a small little liquid cell for our deaerated water. So we can run your beer through the same process, what would be on a full-scale commercial plant, and we go through the difiltration process, and then we would ship you back the beer concentrated so that you could do further evaluations at different bench blends at your brewery. We also encourage you and invite you out to the facility to meet the team, see the facilities, and really get you the hands-on experience of walking through. All right, so now that we either have our seltzer base and or de-alk beer, we look to mix blend and downstream processing. So typically what we do in regards to blending and mixing, we have dilution and the additions of flavors, sugars, preservatives, color. This would be more towards the seltzer, but also relative to de-alk beer. Carbonation is important when on the way to the filler. Through the process of filtration, we've lost some carbonization inherently, so we need to get back up to carb spec. And then pasteurization, so the thermal treatment for increased shelf stability is very common in both applications for both seltzer and for de-alk beer. So when we talk about mixing and blending, what is our goal? To consistently create a homogeneously blended, delicious tasting beverage while mitigating the risk of human error during the process. So we offer a couple of solutions, one being our batch mixing solution called the die batch, as well as inline blending utilizing our DICON technology, which I'll give you a high-level overview of now. So this is an example of a complete build out of a die batch system. And what is it? It's completely customizable for your process and whatever your ingredient needs are. It's a pre-assembled skid that's piped, wired, and tested. It's great for multiple product changeovers. It's very CIP-able and versatile. So we'll talk about the different ingredients that we can add. So whether it's a dry ingredient, utilizing bags, pre-weighed powders, complete bags, super sacks, can all be handled through the system. Small ingredient containers, especially, maybe you're just dosing in a really concentrated extract, we can do that. Drum and totes, IBC totes, so from small drums, 5-gallon pails, all the way up to the big IBC totes, we can handle all of those, either whether it's partially emptied or fully emptied. All of the ingredients are directly and accurately added based on your recipe, and then we also utilize flush water to rinse containers to make sure that you are utilizing all of your ingredients, and that flush water is actually created in that flush water is used in the recipe calculations to make sure that you're not over or under diluting. Here's an example. This is a complete process flow of all of the technologies in one. Not that you would be utilizing all of them, but maybe some. As I mentioned, big bag mixing of powders, small bags of powders, whether you need to utilize high shear mixing, potentially inline heating to help dissolve those ingredients, bottle emptying, drum and tote emptying, all that would be then supplied essentially to what we call our premix tank. And so this would be all of your main ingredients that you would use for a seltzer downstream. And that's where we talk about our inline blending solution, which is our Dicon system. The Dicon system has been around for a long time. We use it in many different industries, as you can see listed here: fruit juices, soft drinks. We use it a lot in the beer mix seltzer worlds, or RTD worlds, ready to drink beverages, dairy, home and personal care. So we utilize the same technology to make sure that we're dosing in the right amount of chemicals into the soaps and lotions that are probably in your bathroom now. So bottom line is a precise ingredient additions. So what we talk about is continuous inline blending, where essentially liquids are mixed in the pipe. The flow of all the streams are consistent and ratio controlled. The product leaving, essentially the system is in spec. We do put a small buffer tank on the discharge just for normal process reasons. We utilize mass flow meters to help control. We can accommodate many streams depending on what your needs are. In a simple example, this would be a simple three stream blender, where your main stream, and if we're talking about seltzer, would be your water stream. Your second stream would be your neutral base, and then your third stream would be your ingredients that you just previously pre-mixed in your pre-mix tank. And then, of course, what's coming out is all of those things mixed together at package spec. So some of the advantages: you don't need a bunch of tanks. You're doing it all in line. You process the amount when you need it. Not a lot of footprint, so low space requirements. You can have many brand changeovers if that's important to you, if you're doing a lot of different products that you're trying to get out. You don't have to save time. A lot of times people that are mixing up in these big tanks, it takes a long time to make sure that they're fully homogenized due to stratification, whatever ingredients you may be using, labor savings, and a big thing, the quality control for in real-time inline blending. And again, as I mentioned, we have a lot of experience in this technology. So now that we have our, whether it be your seltzer base that you've mixed with your other ingredients, or perhaps the de-alk beer that you had mixed with other ingredients, we need to carbonate it. Specifically in the seltzer world, we look to our Dicar-C, which is our inline carbonation. So why would you do it inline versus in a tank? One, it saves time. It's a single pass. You save money. You're not just bleeding CO2 out through the top of your tanks. It helps to eliminate foaming, and as well as tank stratification, which may occur if you're using a carb stone. It automatically compensates your product temperature. It's very hygienic. as all of our equipment is, and repeatability. So hitting that constant carb spec every time. So now that we've carbonated, whether again into seltzer or de-alk, we have the discussion of pasteurization. So why do we pasteurize? So it's essentially the definition you can see here: partial sterilization of a substance, and especially a liquid, at a temperature for a period of time that destroys objectionable organisms without major chemical alteration to the substance. So basically, bottom line is we want to make sure that the product is safe, is shelf stable for as long as possible without impacting any of the quality of that product. So just a brief history: 1862, the first test by Louis Pasteur were on wine and beer. In the 1920s, the first HTST, high temperature short time units, were produced. And today, flash pasteurization is really the most common means for protecting a multitude of different industries, specifically in the beverage industry, for dairy, juice, beer, you name it. As a side note, there is a PU formula that we talk about targeting specific pasteurization units, and there you can see the equation. Basically, the bottom line here is that the formula for beer is not the same for all products. So, as a craft brewer, if you're starting, if you're looking into flash pasteurization, and now you're starting to add a lot of different ingredients, fruit juices, for example, you may want to examine what PU formula you are using and if it is correct for the application you are doing. So our answer to flash pasteurization is what we call our EcoFlash flash pasteurizer, which can be used for seltzer and carbonated beverages. Focused on efficient heat treatment and stabilization from a microbiological concern, quality and flavor stability. We have a variety of different sizes of the flash pasteurizer, from anywhere you can see here, 20 to up to 900 hectoliters an hour. The big thing is that they're very reliable for your product safety. They're fully automated with self-controls, touchscreens, modular and skid mounted. And then we operate at up to 16 bars to make sure that your CO2 is staying in solution. Some of the key features is a 3-stage plate heat exchanger with energy recovery rates up to 96%, which is, I would say, unmatched but by those others in the industry. We use positive pressure gradient for protection in case of a plate failure, so you're never going to have unpasteurized product going into your pasteurized product. Mixed proof separation of the pasteurized, pasteurized product. And then, of course, just like everything else that GEA does, sanitary and design, we utilize sanitary components, integrated CIP concept for the ultimate cleanest equipment. So post filtration, we've now either taken our seltzer base and we've added our de-alk base. We've added our whatever flavors and ingredients. We've carbonated it. We've flash pasteurized it, and so really now we're ready to send it to the filler. And I'm going to hand it back over to Pierpaolo, who's going to walk you through the all-in-one and tell you a little bit more about this interesting technology.
Thank you, Eric. Thanks. Great presentation, and thanks for all of you that are still with us and for your time today. Yep. I'm going to carry on, and I'm going to go into the packaging presentation section here. So, and yeah, I'm going to start giving you an overview about Vipol and GEA. So Vipol is GEA Vipol is based in Slovenia, and it was established in 1991, and is specialized in equipment for filling beer, non-carbonated and carbonated beverages, hot and cold, and a large variety of containers, so can, glass, aluminum bottles, and PET. And in 2018, they joined the GEA group, so they are part of the family now. So they, as we said, they are active in glass bottle filling up to 750 bottles per minute, can filling up to 1000, and PET up to 500 bottles per minute. But what we are going to focus on today is the all-in-one, which is the flexible and compact version of their all-in-one filler, or our all-in-one filler, dedicated to multiple bottles, multiple containers, so glass, PET, and aluminum containers. So this is an installed base for the company. We started working in the US in 2018, and we have now close to 10 installations in the country. So we have been developing this market well, and there is a high demand for this flexible solution now in North America. We are present in Latin America, Asia, North Africa, and Asia and Southeast Asia. Is not only the filling block, we also have the capabilities to provide you a turnkey filling line in partnership with other established companies. So it's just not the filler, but it's a turnkey packaging line, starting from the palletizer up to the palletizer, including the palletizer machine, including conveyors and packaging and labelers. Now we're going to focus on the all-in-one filler. So it's a flexible and space-saving solution for can, glass, and PET bottles, all filled in the same block. Speed ranges from 50 to 420 containers per minute. And if we look at sizes, we can go from 150 ml, so 5 ounces, up to 100 ounces. It's suitable for still and carbonated drinks, hot and cold filling, and all varieties of products, CSD, carbonated, non-carbonated, wine, and spirits, and beer. So it's an excellent choice for small and medium-sized plants that don't want to invest in multiple lines, one dedicated to glass and one dedicated to can, for example, but want to have a single machine that can do both based on the market trends and future market trends. And also is a good application for a pilot application when you have the need to go low speed but test a different kind of containers. Yeah, this is a typical footprint of the machine. So on the right bottom here, you have the containers coming in at the ground level, and basically 4 or 5 feet above ground level, you have an infill screw. Then we go into the rinsing machine. And in this rinser, we basically twist the containers upside down. It can be an aluminum bottle, it can be a can, or an aluminum can, or it can be, for example, glass bottles. So we basically apply disinfection media inside the container. We can have up to 2 different medias. We go into the filling machine, which can be electronic, volumetric, or with short tube. And again, same filler for the 3 containers. And then we transfer the bottle into the capping area. In this particular case, we have 2 turrets. One is dedicated to crowns and a simmer for lid in the same crown, in the same carousel. Or we can have, in order to increase flexibility, we can have an additional one, for example, for aluminum cap or PCO caps, plastic PCO caps. So this is going to basically give you a total flexibility. Yeah, so we talked about the rinser. It's approximately 4 feet from the ground, the entrance, the inlet conveyor, and you can use the same depalletizer for glass bottles and can. And the carousel is equipped with the universal rinser grippers, and they can be used for glass, can, and PET bottles. There's no change necessary because we have an automatic height adjustment, and we can grip the container at a different height, and basically that allows us to have basically a very flexible gripping pads. And it can be designed with 1 or 2 separate channels, allowing the usage of different rinsing media. Yeah, the filler is volumetrical, using a magnetic flow meter, or we can have it a short filling tube version. The filling valve are electro-pneumatically controlled, and we can have single or double air evacuation for all containers. This is to reduce oxygen pickup, and this is also true for aluminum can. This is the centering valve. This is a changeover required when, for example, we switch from glass bottles to aluminum can. It's a manual changeover, and basically this is the only part that it is required to be changed in the machine, going from glass bottles to can. And this is the part of the block where the biggest innovations are. It's a single capper carousel, and basically with a combination of a simmer and a crown applicator. So as you can see, we have in every other pitch we have a simmer, and then we have a crown applicator. So basically you can run can and aluminum glass bottles without any mechanical intervention. You just basically change the pitch of the carousel, and this is going to allow you to use either the simmer or the crown applicator. So, and for can we are including undercover gassing to basically eliminate oxygen from the headspace, and we can also include hot water injection for glass bottles, and the carousel is activated by a brushless motor, so it's very easy to change basically pitch and work either with the simmer or the crown applicator, the crown. And we can provide also the machine with automated lid feeding system for the simmer with approximately 20 minutes of buffer time. And we can also apply lid disinfection. So you have the chance to basically disinfect, for example, your can, disinfect the lids, and pressurize the machine with HEPA filter laminar flow. That is going to allow you, going to give you the chance to basically produce in a high-grade, ultra-clean filling environment. And we talked about glass and aluminum containers in the same block, but another application is running different can sizes in the same block with different lids. So, for example, we have an example with standard can or slim can or king size can. All of them have different lid sizes, and we can basically equip our simmer carousel with different roller sizes. So you will have the chance to switch between all the three cans without the typical mechanical changeover that is required for standard simmer that is going to take hours. So this is we can do that with a simple touch manual operation in the HMI. And if you want to add additional flexibility, we can also add an additional turret where you can have ROPP aluminum cap for example, aluminum bottles or glass bottles, or we can apply PCO capping, so typical plastic screw cap. As we discussed before, we can upgrade the system with an ultra clean application with the laminar airflow, and we can have lid disinfection, and that's basically if designed in the right way and with the right treatment on your product, you can reduce or eliminate the need of a tunnel pasteurizer. So just to give you an idea, format changeover from aluminum can to a glass bottle is between 20 to 40 minutes, depending on machine and size and configuration. This is with one operator and tool-free. So we go into the details here. It's 10-15 minutes to change for changeover parts. So basically transfer star wheels and counter guides, which are all tool-free. We have basically we need to apply a change on the rinser, but this is applied just using a touch panel, so there's no mechanical changes on the machine. There's no manual intervention. Then we have 10 to 25 minutes required to change the centering bell in the filling valve, and the other change on the simmer capper is just using the touch panel. So there is no any mechanical intervention to switch from using the basically your crowner or your simmer for the can. And the same is for, as we discussed before, the same is for changeover between can with different lids. So we can go from a standard size to a slim size between using usually 10 to 40 minutes, one operator, depending on the machine size. So again, definitely much faster than a standard mechanical changeover on a standard simmer for can. And this is just to give you an idea about, on the left side, we have a layout for a typical glass line layout, and on the right side, we have an all-in-one layout. So basically a layout for a line capable to do both aluminum can and glass bottle. So the depalletizer can be a flexible application that can do both. And outside the depalletizer, you have the chance to go through a labeler if you need to, or you can bypass the labeler. For example, if you have pre-printed can, and you can go straight into the block. And usually on the packaging side, you might have one packer or two packers. It depends on your requirements for secondary packaging, and then you go into a palletizer, which is universal palletizer. So if you look at footprint compared to a dedicated glass line, is not really much bigger at all. So obviously, by processing cans, glass, or PET bottles, or hot and cold in the same line, there are significant savings potential compared to having a conventional filling lines all dedicated to each single container. So, and yeah, certainly floor space is a big advantage. Instead of having multiple lines, you have only one line, so there is 60% less floor space that you're going to need. And obviously, that means lower investment in building, lighting, ventilation, and energy. And yeah, a combined can glass filling line also requires a reduced amount of equipment in the plant, so less time and material for maintenance, reduced stock of spare parts, and obviously higher rate of utilization because the line is constantly utilized, and there are no basically time where the line is idle because you don't have enough capacity. You always have flexibility to run can and glass or other containers in the line. So in a few words, a lower OPEX and CAPEX. So thank you all for the time you dedicated to us, and thanks for the Brewery Association to give us the chance to give you this presentation. And again, what you have here is our email addresses, and please again feel free to reach out to us in case you might need additional details and information or quotation. And yeah, you also have our website here where you can have access to a lot of additional information about our product portfolio, and you can always find us on Facebook, GEA Car Brewing. No, thanks a lot, thanks for your attention, and we hope we will see you visiting our booth at the show. Thanks a lot. Thank you.